Well, welcome everyone to the April 2018 edition to the ForecastBuilder webinar series. Just as I always like to say about ForecastBuilder here, that this is really just a program here to lay the foundation for IDSS via a consistent science-based process. For today's webinar, we actually have a lot of different things here to cover. I've got the topics listed here. We'll talk about a new communication method that we've put in place here for ForecastBuilder so you can reach the group. I'll talk about a couple recent weather events, some of the changes we've had, some topics about summer items to review here. We'll talk a bit about ModelCertainty tool update. This has been a pretty big update in this in the recent release. Items in development, and then open it up for questions for everyone. All right. So the first big thing here, and this is great for your forecasters, is the development of a new NWSChat room called ForecastBuilder. So you can just join that room, just as its name, ForecastBuilder, keep it easy. It's monitored here by the group, and it's great for forecasters to ask quick questions on anything science or technical during any shift, since some people here in the ForecastBuilder group are on rotating shifts, so some of them might be around to help to answer questions. And we've already tested this out a little bit here for this recent winter storm in Central Region, and we had some responses going on during the middle of the night on topics like blowing snow. And two, this room is a great place for like me, for example, to post some informative tips about a storm that's impacting somewhere across the weather service and what might be useful in this certain situation. For example, especially here late in the season, a road temp grid can be of help when you've got freezing rain going on that you're only expecting to impact elevated surfaces. Obviously, we still have our virtual lab site available, where we have FAQs, a good forum section if you don't have something that you want an immediate question answer to, but would still like to get a response. That's a great place to put it. It's a good training resource. Note that we are looking to move this out of the CRSU since ForecastBuilder is being installed and expanded, tried out across much more of the weather service. So that's being investigated at this current time on how to do that. So probably in the next ForecastBuilder webinar, which usually comes in about 2 months, I'm hoping by then we'll have a solution to that. And finally, there's always the email address there, the nws.forecastbuilder@noaa.gov, that you can always send questions to. All right, so let's talk about some recent events. The first, I really want to just do a little NBM comparison, primarily because the science technique to develop precipitation types, snow and ice accumulations that's in the NBM is exactly the same that you have in ForecastBuilder. So we'll take this one of the 4 nor'easters, this one being one of the ones that had some of the strongest winds with it, this March 8th, 9th one. Just to do some comparisons, this is a 24-hour snowfall here during this time span from. So this is looking a couple days before the event, and where the NBM had a little higher snowfall up in Maine versus NDFD. One of the things you do see nicely in this image is the little terrain features in the NBM, and you see it in the NDFD as well, but it's good to see the NBM picking it up there across Western Mass and Central Mass. If we actually look at some verification numbers, now on the right, I actually have the 24-hour snowfall amount forecast for the first 24 hours of NBM. You'll notice that there was more snow closer to the coast, including the city of Boston. But you still again see those same terrain features both in the observed analysis and in what was forecast. So that was good to see. Definitely the higher amounts picking up on, maybe in some cases a little underdone, but got that impact sense nonetheless. So some of the issues with on the coastal region with this storm, a lot of it going into the temperature forecast, and the NBM was a little warm with that. And this is where like I say, the NBM being that idea of a common starting point, where the forecaster can come in and make an adjustment, and you can if you adjust the temperatures down, you'll get increased snowfall. And I just really wanted to show about how this temperature played into the uncertainty, especially for the snow amount at Boston. You can see the great spread in some of this SREF guidance from that was anywhere from a couple inches all the way up to like 15 plus, and really just showing that uncertainty with how does the temperature stuff, even to some degree probably QPF as well, but that temperature was a huge problem. Next event, and that's just this recent one here that happened late last week into the weekend. It's one of the most complex storms I think we've had to deal with in years, probably for at least the central part of the country, with so many different facets to it, and a lot of different oddities played out during the course of this event. I've got a lot of the various issues here listed, not to dwell into any single one of them at this moment, but I will want to show how complex this was just from an LSR map. And you can see the wide swath of snowfall LSRs with some, and I know there's some icing LSRs in here. You've got heavy rain ones, the severe aspect, high winds, and all that going on. Let's take a look at the snowfall side of this forecast, and on the left is what you see from the 72-hour snowfall, and good, great consistency in the NDFD images on both of these, and very nice job in terms of highlighting where a lot of the heaviest snowfall will fall. I mean, you compare, like NDFD and no risk, but was eventually observed, and I mean these line up pretty well. Yes, there's more snow in the Green Bay area, but if you look at it from the impact sense, I mean, you got that wording out. And I did show the NBM in here for comparison. And some of the snow on the back here is, you don't. I think a lot of this is just due to timing in terms of when I kind of grab these images and where they sum up to. So you see a little bit more out here in the western part of Nebraska versus what's shown in no risk. So I would probably ignore this section. But the rest of it, you can see lines up pretty well. And even go into the next day, a couple runs later in the MBM cycle, and again hits very nicely. The icing was this icing was a tricky one because some of the QPF was going into a refreezing process, and even that was tricky amongst the models, where the NAM, for example, in lower Michigan leading up into this event was a little more weighted on, or had a little more refreezing potential than either the GFS or the Euro had. So anyway, on the left, you'll see that both, the NDFD and MBM picking up at some pretty high values for icing. These eventually got trimmed back, and you can even see that here as you got towards the 15th time frame. And some of this again just due to because you're in a shorter time scale now in the event. Observed icing was actually only on at least for Grand Rapids area, maybe upwards of a quarter inch or so for icing. Nonetheless, there was numerous impacts across lower Michigan. Another icing impact, and I think this one's fun from a science perspective, was out in Ord, Nebraska, where one of our weather radio towers, the tower got blown over, and there was a significant amount of icing that was, and you can see that here on the meter. And so I took a look back at the observations, and there's not one freezing rain ob in here whatsoever. The winds are gusting 40 to 50 knots. So I think there's two questions to ask about this, because the Ord was kind of in the blizzard deformation side of the system. So what's with the freezing rain? And two, how do we get this much icing? So I'm going to talk about both of those aspects. The first is what's with the ice being in the deformation zone, and the main reason is the prob ice present. And on the right, I've shown an image from the 0Z run of the MBM on the 13th, and look at how these low values of prob ice are wrapping in all the way back into Nebraska into the deformation zone area. So you had a lot of these areas where they were getting, you'd be in freezing drizzle or maybe even freezing rain, then going over to snow and then maybe back again, or mixed at times. And I could even make the argument, because of the Ore, Nebraska is kind of located right about here where this 96 is in front of my mouse cursor, if you can see that. The prob ice presence was even probably lower than what was forecast here. And thus, I know from reading some forecast discussions out there, this definitely impacted in terms of the blizzard warning verification, but in terms of impact, yeah, I mean, you had plethora icing with problems from that. You had the snow, you had the wind gusting 40, 50 knots. So, I mean, it was still a problem nonetheless, and definitely did want to be out there. Then the other side of this question is, why so much ice accretion? I read some Hastings AFDs, that there was freezing drizzle around and observed. So, when I go back to those observations, there could have been some freezing rain, or even, just flat out at least freezing drizzle, maybe some freezing rain. I noted that the present weather and ice accumulation sensors appear to be out in the observation. But even then, I was like, okay, still, how do we get this much ice? And so I talked with one of the FRAM authors here, Brian Bargenbuck, the Sioux at Omaha, and going back to some of the research, if you look at the precip rates for like the lower end here, when you're only looking at maybe 100th or 2 of an inch per hour, and your really strong wind speeds, those ice ratios are like 3.4 to 1. But if you decrease those wind speeds to less than 10 knots for that same amount of precip rate, your ice ratio is like 2 to 1. And in just a general sense, this can be shown nicely graphically. And I think this is in the FRAM training, that as your wind speeds increase, you will increase that ice to liquid ratio. So you can get more ice accumulation with higher wind speeds. So I think this is, you've got obviously some of the issues with the observation, but I think what we're seeing is a little bit of this, where we're getting higher amounts of ice ratio. And to honest, there's not a lot of cases of these with 40 to 50 knots of wind and experiencing this freezing drizzle and all that in the FRAM data set. So, but this is a very interesting case. Again, this whole event has got a whole ton of different interesting oddballs to it, and this is just one of them. All right, so let's talk about ForecastBuilder updates. One of the biggest things is that we moved ForecastBuilder into its own location on the SCP. We got it out of the CRGFE tools package, and now it's on its own spot. Since we're getting lots of offices outside Central Region installing it, making it more of a national thing here. We've got some blow and snow tool updates that were mentioned in the February webinar. So bringing in no-risk stuff, but unfortunately there's something recently changed with their data files, and it's causing occasional problems with GFE. And so the next National SmartNet release will have a fix for this no-risk issue. It's a new probably severe tool, which we'll talk about. The ForecastBuilder can now utilize the time ranges in the GFE Grid Manager. I know that was kind of an issue for a lot of people, that the times in ForecastBuilder weren't matching that of GFE. So you can change that in a configuration item. For those offices that have been testing the edit retention add-on developed by Ryan Leach up in Missoula, that's now incorporated. So you can now try that out through the whole ForecastBuilder package. A couple of data additions, because we request about freezing fog to be added, and that's been put in, and see the thresholds there for the task directed. And we also added seeing high invisibility elements to be published, and finally lots of updates, major ones to that at the ModelCertainty tool. Now to summer review, talk a little bit about probability of thunder, and this is a difficult problem to solve, and I'll come with a summary here in a minute. Not stated directly in 10.201 or 204 about what the probability of thunder definition is. So if you go back to the FMH1 manual, the by a thunderstorm definition, it's thunder heard. So the idea here is that our probability of thunder forecast should be probably representing total lightning. Well, there's a big problem. The SRF thunderstorm probabilities were developed fit in some SPC needs, which were 1 or more cloud to ground lightning flashes. And there's these different things else that are used, including specifically QPF has to be greater than or equal to 100th for the probability to kick in. There's a nice presentation on the ForecastBuilder VLab site about it. So like when you look at the SRF thunderstorm probabilities, they're going to be low because they're cloud to ground and the calibration. We also have grid and MOS, which ForecastBuilder you can utilize, or actually does utilize. But the problem is for grid and MOS and all MOS for that matter, calibrated is also cloud to ground lightning. Now, LAMP did produce a calibrated product with total lightning on this website address listed here, but that is not on the SBN yet as far as I know of. So what do we do? Well, in ForecastBuilder, you can utilize the probabilities from the SRF, MOS Guide, and gridded lamp. Again, the gridded lamp in the case for ForecastBuilder, what's coming into AWIPS is the cloud to ground calibration. So, you know, they're going to be great for timing, but the values are going to likely be low. So use like a tool like Strength Stretch, and that will help make it fit more of the idea of total lightning. And then just probably collaborate that up, obviously. Then there's also the second approach in ForecastBuilder that you can utilize. This is in the GUI for where you can utilize POP as a proxy for probability of thunder. And, you know, that works, I think, good for a good chunk of like the summer months when most showers are produced in thunder. But in some cases, utilizing POP will be an over forecast. So keep that in mind. Hopefully, with the gridded lightning or with the Go16 GLM coming online, you know, we'll get some of these probabilities calibrated to total lightning. I will say that if anybody out there has some other ideas on how to compute a probability of lightning, you know, send them to our nws.forecastbuilder@noaa.gov email address. One of the tricky things with trying to do this too is not trying to set like a threshold level. Like, you know, hey, CAPE greater than something will be 40% thunder, CAPE greater than something will be 80% thunder. You know, need some kind of maybe some nice curves to it, something like that. You know, like what you would see out of the SRF thunderstorm probabilities. Talking probability of severe here. Next up, in this latest update, we brought in some stuff that Bismarck had developed, which basically helps bring in the SPC convective outlook probabilities in combination with the SREF to help assign your probability of severe. And remember that where the probability of severe value is 30, you'll get the T plus in the weather grids. Note that you will get T plus in the weather grids if you have a severe thunderstorm or tornado watch out for that specific watch area. And just in the example image here, it will create the probability severe day 1 through 4, which matches where we have data for the SREF, and most of it we have the data for from the SPC guidance, and that can be, you know, that can be shown here. Actually. Next reminder, frost. I know we've already got offices dealing with frost because our growing season kicking in. The air mass here in April's been pretty cold. That tool is utilized in a University of Kentucky Ag study where we've got temperature, dew point, wind, and sky incorporated. No frost will result for an hour if either of those conditions are met, whether you got a high dew point depression, some strong winds, or a lot of sky cover. Note that POP here still needs to be considered for inclusion. That has not been done yet, but we will consider that. Quick reminder on computation and POP. I know I've given this in a few ForecastBuilder webinars, but since we've just switched over to into April, I want to let you know that for those that are utilizing SuperBlend in ForecastBuilder, and populating with it, it's the QPF. The POPs are based on QPF, just a pop from QPF curve. Whereas in the cool season, we apply a neighborhood POP technique to SuperBlend. The con short data set is neighborhood POP year round. And then finally, NBM is a blending of some neighborhood POP technique and QPF from POP technique through 84 and neighborhood thereafter. One thing that's interesting doing some verification, if you trust the IRMA QPF as a QPE as a truth grid, that the NPM pops using this kind of technique that they have are actually it's really good. So most other pops are usually under forecast. So I know that there's been times that we've questioned about some of the pops that have come up in the neighborhood technique, but in the cool season. But yeah, they've verified. If anything, they could be higher. So I think that's kind of unique. So on to ModelCertainty. Again, this was a big upgrade in this recent release. So I'm going to pass this over to Jerry Wienenfeld, who's the ITO at Milwaukee, who's done a lot of work on ModelCertainty.
Hey everybody. So the idea with ModelCertainty tool is it's a tool to provide some statistical information about the models that are in GFE. And the idea here is we want to provide this information so we can make targeted grid updates based off of it, and as well as even supply some information for DSX activities. There's been some people here, even at my office, that have actually turned around some of the new additions and put images actually up onto the web. So there is, and I'm going to talk about this later, but some updates will be actually some direct imaging from this tool as well. But as far as the updates with this latest build, I've added wind direction, some storm total snow grids, cloud-based primary visibility, max wind gust, wind chill, heat indices. So a lot of elements. I've also added some models in there that were not in there before. So there's a pretty extensive model list. Another big addition is the ability to do box and whisker plots. So you can run this and on any individual edit area. If you don't select an edit area, it'll actually default to your entire CWA and actually produce a box and whisker plot to show sort of the distribution of the models as well as the box and whisker. And you can do something similar for wind directions, but it's actually wind rows. And I'm going to show examples of those here as well. And then the final thing, which I find could be very useful for threat events, is some probability grids. And these are based off of the percentile information. So the probability of temperature being less than 32 degrees, or if you're looking at, a heat problem, you could look at the heat indices greater than 95 degrees or whatever your threat levels are. Max wind gust you could look at. So a number of avenues here. And the final thing is these warm tail, cool tail, and I actually didn't put it down here, but some skew information. And those are all based off of the warm tails and cool tails. And it looks like we're...
Yeah. I apologize for that. I do not know what happened to the webinar presentation, but we'll get that back. All right.
All right, so I think we can go to the next slide there. Yeah. So here with this one, I was just going to show some quick examples of how the GUI is used. So with storm total snow, basically you'd select a time range, and it'll actually accumulate the snow amounts from the GFE snow grids and over that time range. And from there, you can show individual models. So this is a really quick way to see what all of the individual models are thinking will be for this storm total. And so this image here on the left is what the grid manager will look like. And also new to this build is before it used to put all these temporary grids sort of at the bottom of the grid manager. In order to clean it up and make it a more representative of what we're looking at here, I've sort of gotten rid of all of what may have been in the grid manager and put all these grids up. This should be fairly similar to how everybody should be used to ForecastBuilder and how it goes through modifying the grid manager. So this is just a lot of people use this tool strictly for this purpose, to get an idea of what all the models are saying. You can get max min grids, and so that's a max of all of the models at each individual grid point, and then min, same thing. With prob snow experiment that we had, this is sort of another way to look at it, just strictly from the models that we have in GFE. You can get the 10th, the 90th, and the 50th percentiles. And then also, as I was talking about with the skew, that's also in there. So that's just an example of one way to use it. Now let's go to the next slide. So here's an example of the box plots. And in this particular one, I did MaxT, and I included all the bias correction models here. If you're not familiar with it, in GFE, when you're selecting things, you can use the Control or Shift keys to select multiple models or deselect multiple models. So here, I've chosen to do a box plot, and so as you can see by the red square, and just some quick information. The box plot has a lot here. These red dots are what all the individual models are. The variation sort of on the X coordinate, that's just so you can see the dots. Otherwise, it would be in a straight line up and down. That black square is the star. I also have the red line is the median, black line is the mean, and then the box itself, that's the 25th and 75th percentile. Anything that is outside the 90th or 10th percentile will come out as outliers, as a green diamond. So lots of information that you can glean from this, and you can also do this over a whole period. So just recently I was curious here, and I grabbed the whole 7-day period, and it'll actually show the box plot of every one of those dates. And again, that's using the CWA as the edit area. So let's go to the next slide. And here's an example of the wind rows. This I find very interesting, because one of the complaints that I've seen in the past with SuperBlend is, what if all the models are saying in different direction? The low pressure system sort of depicted differently. So right away when I got this running, I went to a day where I felt like that might happen, and it's very neat to see. You get one big pink circle, and so that, you know, on that particular day, that might be a target that offices would need to zero in on to try to figure out where the best location of the low pressure system is. So that, again, this is what happens whenever you select the box plot or wind rows. It'll create this, and you can also do it for, I think, up to 36 periods is what it will show. So if you're selecting it from now until 36 hours from now, you'll actually get 36 wind roses onto the figure. Next one. All right, so here I'm just going to show a really quick example of how the percentage grids work. So I'm doing it for the min-T, and I was going to do it for 32, less than or equal to 32 degrees. And then this is what it shows. And in this case, I also am not showing all the individual models, just to show only the stats that can happen. One neat thing is you can see this min-T SD. It's highlighted red, and that gets highlighted red whenever you have points within your CWA that exceed 2 standard deviations. So that's another quick way of sort of seeing where there's a lot of uncertainty in the grids. But the particular case that I was looking at is the min-T prob less than or equal to 32. I wanted to get further out where we actually may have some warmer values here in Wisconsin. So the next image will show that. So this is showing what the models are depicting as the chance of less than or equal to 32 degrees. So northern Wisconsin, they're going to still probably be stuck in the cold weather 6 days from now. But as you can see here in southern Wisconsin, the chances are that a lot of the models are suggesting that we could start warming up, hopefully. So we'll go to the next one. I think that may actually be it. Yep.
Mm-hmm. Well, thank you very much for that, Jerry. And I think just to sum up, this is a really nice tool. Again, we put it in that target of opportunity tool set, and really to show like this a statistical distribution of where time periods where there's a lot more spread versus those that there aren't any, or if you want to look again like your specific threat thresholds. I think all that would be good for it. All right, coming up here to the end of the presentation, we can get to some question and answer time. So what's in development for ForecastBuilder? Incorporation of fire weather into ForecastBuilder. We've got led by Pueblo and Bismarck offices, and we're taking in feedback through that process. I know we've been taking some feedback out of some Southern region and Western region offices into this, so that's going to be excited to look forward to here over the coming months. A new ForecastBuilder GUI design and options. That's one of our development group #1 priority to get that going, because we know that there's some issues definitely with the current GUI and impact when other tools are run. It can kind of distort the current GUI, and current GUI crashes. So again, we're going to completely revamp that, and provide new things in that. And then again, as I kind of alluded to earlier about the edit retention, developed up in Missoula, again, that's on the SCP, and to help maintain local effect information. So it's like nice little targeted, and where you can just do specific areas, and only apply when changes would affect the messaging in the forecast. So I think that's something to look forward to going up, looking forward in time. We'll talk more about that as the development continues. And that's it. I'm going to now open this up for any questions. Again, I want to make sure everybody's aware that ForecastBuilder NWS chat room is available for forecasters to ask questions anytime. All right, feel free to raise your hand. Or post a question in the question box. On that, we do have a question about the ModelCertainty tool. Is there, and Jerry, this would be a good one for you, is there a way to see what models are the outliers?
Well, with the box and whisker plots, that is on my to-do list. One of the things I want to do is to add the rollover capability, so that you could roll over the dots, and that would tell you which model is which. I also want to add legends to the box and whisker plots. As far as within the grids themselves, I know that was one thing that my Sue here, John, has been doing a lot of fun work with, is you can sort of, when you look at the individual models and then you can see sort of the max and mins, you can start seeing from the max and mins which are your outlier models. And then the really neat thing is you can start adjusting sort of the distribution and the spread if you start removing those outliers. So one of those models ends up a lot of times being the adjusted men, or in a wind event, you can pretty much count on getting rid of all of the bias correction models. Yeah, I mean, those are just a couple ways, but yeah, that's something I'm definitely going to be trying to add. It's going to cause a lot of coding to try to get those rollover capabilities into the box and whiskers.
Oh, Jerry, one more question here about the ModelCertainty tool. If you can explain a little bit more about the warm tail and cool tail.
Sure. So the way I developed the warm tail and cool tail is basically taking the 90th and the 50th percentile and subtracting the two of them. And so that I call the warm tail. The cool tail, then I do the same thing. I subtract the 50th minus the 10th percentile. And then for the skew, I actually subtract the warm tail from the cool tail. And so the idea here is you're looking to see which of the tails is bigger, and that's sort of what the skew gets at. You can start getting an idea of which way the distribution is leaning, if it's leaning towards the warm side or the cool side. And again, that's where, getting rid of some of these outliers in the distribution can help. You can start getting more of a normalized distribution if you get rid of some of those outliers. So that's just a real quick idea of what the warm tail, cool tail, and the skew is. The way I've told my forecasters here is if you're hedging one way or another, the warm tail and cool tail may help you with that hedge. Whether or not you can feel like maybe there's a couple models pushing you a certain way, that could help you. And I also wanted to, I guess, further explain that probability grid where you're looking at the thresholds. So that grid, I'm actually looping through the entire percentile, like the entire CDF. So I start at the 0th percentile and go all the way up to the 100th percentile. So there is a ton of calculations going into that grid. And then as soon as I hit the threshold, that's the probability of it. So when you think about the massive amount of grids that it's calculating and then all of those CDF computations, it's pretty impressive. And it actually gets it done in, I mean, just literally seconds. So there's a lot going into it. It's not just like the standard SREF type probability of which you're, counting up the amount of models that or members that hit the threshold. This is actually looking into the CDF itself and sort of flipping the CDF into a PDF.
What you're saying, ModelCertainty is a beautiful statistical tool.
It's pretty impressive what you can do now in Python, especially within GFE. The NumPy package is pretty impressive.
All right. Are there any other questions? Feel free to raise your hand. Post it on the question box.
It looks like there's a question about the edit retention tool, Andy.
Oh, yep. Yes, for edit retention, as far as for Central Region offices, I wanted to let everybody know the Central Region Grid Methodology Advisory Team is evaluating it. It's looking likely that we will implement that. We haven't formally came to that yet, but just doing some testing, it looks likely. We've been providing feedback to the developer on some things that we'd like to have adjusted, but it's possible sometime here this year that we'll implement. Any other questions? And two, you can always send a comment to the NWS.ForecastBuilder email address. Otherwise, we'll have our next webinar here probably in a couple of months, looking more again at summer items. And with that, have a good rest of your day.